AZ500 Part 2. Continue our discussion for the exam prep slides. All right, next topic, ACI container group. Now, you may have known that AKS, Kubernetes services, have a concept of container pods. The idea behind the pod is that one or more container within the pod will always be scheduled on the same physical nodes. So these pods communicate directly internally with 127.0.0.1 loopback. Okay, so they don't have to even touch the network stack in order to talk to each other. These pods also guaranteed to share the same file system. Okay. So if one of the pod writes out to a volume claim on the local machine, it's guaranteed to be readable by another container in the same pod. All containers within the pod, they either all come up or the whole pod fails. So just like, P in the pod. So, get it? All right. When we use ACI, Azure Container Instance on-demand container execution environment, we can deploy 2 or more containers as a multi-container deployment, and it's known as ACI container group. Now, there are many design patterns that calls for multiple containers to run together. An example, you have Nginx and you have your web server, right? Your ASP.NET Core Kestrel is a web server, Nginx front end for it. So if you have a solution that has a web server, or 2 web server or 3 web server, right? You may want one Nginx running in a container, serving as the reverse proxy for 3 additional web server. So these containers are deployed together in a single pod. All right. Another example, cache aside. Okay, so you might have a Redis cache next to your application, so they run side by side and they communicate using internal communication really fast, and you get all the features and separations and whatnot. Okay, so cache aside is another pattern. Sidecar, ambassador, there's a whole lot of patterns out there that calls for side by side containers. All right, so if you want to deploy a multi-container ACI, okay, you can use an ARM template. All right, so notice that the resources has a type of container groups. Containers is an array, so let me zoom into that. So container is an array of all the containers you would like to run them on the same host. All right, and we call that container group. So the second container. All right. So that's what ACI container groups do. 2 or more containers running side by side, sharing a file system and communicate privately. And sidecar patterns, cache aside. Gatekeeper. Yada yada yada. So there's a ton of different design patterns that uses 2 or more containers. Now here what you have is a ARM templates deploying a resource of VM extension. All right. To configure your virtual machine to report to a log analytic workspace, okay, there are 2 pieces of information that you must give to the VM. The first one is the workspace ID, and the other one is workspace key. Every workspace has a primary and a secondary key. Either one of the keys is fine. Okay, this is the Microsoft monitoring agent. These extensions can be used to deploy to virtual machines running in Azure. Now, a quick reminder, if you have virtual machine running outside, you're going to have to download the Windows or the Linux MMA agent and install it yourself. Naturally, during the installation, you'll also be required to provide the same two pieces of information: workspace ID, workspace key. All right. Now here, there are lots and lots of log analytic queries. So I'm going to take one. I'm going to walk through what are we looking at. All right. So the first line, this specifies the log we're looking for. We're looking within this table of security event. So in that log table, there's almost universally a column time generated, okay, since 1 day ago. So we are looking back for the last 24 hours. Now that pipe means first filter all the security event, filter based by time generated, send the results to the next pipe. And we're looking for account type and event ID 4625. So this is for failed login. All right. And next, once we have filtered by those two where clause, we're going to summarize by counting how many failed logins. All right. And we are going to look at when is the last time they log in. Okay, so here's an example. Victor had 7 failed logins. All right, and they are spread out within the last 24 hours. 1, 2, 3, 4, 5, 6, 7. All right, so this will create a group that says Victor, the last time the failed login happened. Okay, so let's say the last time it happened was 5 p.m. All right. So the latest failed login, all right, by account. So it'll be Victor, last failed login at 5 p.m. and it has been total of 7 times. All right, so summarize and get the max per account. Now we are only interested in those failed logins that has failed more than 5 times. And we're going to project account. All right, so the things to pay attention to is this is how we filter by things, and column equals, and 2 equal signs, folks. Pay attention to that. It's 2 equal sign, not 1 equal. 2 equals. Summarize something into count. So this is a summarization function. So count by that. There are many other log analytics queries. If you're interested, you can see more of them. All right. All right, and when they last attempt to log on, so that's argmax. So Victor, the last time 5 p.m. and only if they have made more than 5 attempts. All right. Azure Security Center is a value-added service. Okay, we, as a customer, configure our environment in a certain way that we know how. Azure Security Center has some predefined best practices, secured settings, good approach to take care of certain things. So these security center contains lots of policies, and it continuously evaluate against our Azure environment. Hopefully, recommendations can be proposed by the security center to help us operate better. Azure Monitor gives us means to monitor our environment. Azure Security Center help us to run it more securely. All right. So there are two things that Security Center can identify: a threat or a recommendation. When either one is raised by the Azure Security Center, whether it's a recommendations or there's a detected threat, okay, we can respond to those by using a workflow automation, which happens to be a logic app. So the logic app comes with two kind of security center trigger: recommendation trigger and a threat trigger. Okay. So you can lay out how to respond to these recommendations or these threats. Logic app is a graphical workflow. What you see is how you run your code, very much like Visio, very much like IFTTT if you have used those type of things. It's a graphical designer. It's JSON based. Starts with a trigger, logical branches, steps, so on and so forth. So Azure Security Center Playbook respond to the output of Azure Security Center. All right. Azure Sentinel is about security incident event management. So it is a SIEM product from Microsoft. Okay. The Azure Sentinel assumes that you have a secure environment and you do the best job that you can. Running the most secure environment does not mean people will not attempt to compromise your environment. And many times, these attempts to compromise your environment come from many different angles. Okay? They may not be attacking your Azure infrastructure. They may attack a network that has a VPN connection into your Azure. Okay, someone may take advantage of some on-prem AD vulnerabilities and try to use that to compromise your Azure environments. Okay, there may be intrusion detection system that you deploy elsewhere in your organization. Azure Sentinel is meant to concentrate all these data. And of course, its job is to stand guard in your environment. Okay, so all three product, Azure Monitor, Azure Security Center, and Azure Sentinel, they all have a different responsibility. Okay, so the Sentinel's job is to connect to as many systems and let you easily analyze the logs that these systems generate. Okay. Be able to raise incidents because we have limited human power to keep track of all the things that's happening, right? So by using analytic queries, and when the condition is met, create an incident so we can focus on the incident. All right. So we call those analytic rules. There are many templates provided by the data connector. All right. So as we create a new rule, all right, we can run these rules and into alerts, so we can be notified of these anomalies. All right. So this tutorial will walk you through how to create an analytic rules to detect these possible issues. All right. So when you have some time, check it out. This is to protect from external attempts to compromise your system. Now, all three things, Azure Monitor, Security Center, and Azure Sentinel, They're all services. They rely on an infrastructure. Okay, so you can think of them as product built on top of this solid foundation called log analytics. Okay. So this foundation is how we can collect millions of records without blowing up a server. Okay. Take in millions and millions of records and still get millisecond query response. Okay. So none of these services will be possible unless we have an immutable log storage that is REST accessible with a language designed for log processing. So all this feature culminates into log analytics, and only because this is hyperscale, I keep bringing up hyperscale because the scale of this thing is really mind-boggling. Because one organization may send millions of records each day, and you have tens and thousands of business sending stuff to this. And then every time we run a complex query in our millions of records, it just comes back in seconds. And then this is just mind-boggling big. All right, so when you use log analytics to store data, it's a data warehouse, but it can't really store that long. 2 years is the maximum. Anything more than 2 years, keep them in storage. Okay, you can always attach a data brick and then do batch processing there. You can also spin up HD Insight, what have you, to do batch processing. Okay, because after 2 years, well, it gets historical. So we try to keep things somewhat, at least somewhat fresh in log analytics. All right, so you have Microsoft Monitoring Agent. Oops, I said Management Agent. Ooh, Monitoring Agent. Okay, so we got this Microsoft Monitoring Agent. They can monitor on-prems. Okay, you can deploy OMS extensions for Azure SQL. You use log analytics to query that. All right, you can also define metric alerts on these log analytics stuff, performance counter. All right, so go to Azure Monitor. When you go to the metric alerts, you can pull data out of these metrics to create alerts. All right, you're convinced that Azure AD PIM is good for you, and you decide that you want that on your tenant. All right. So keep in mind that member of global admin can enable PIM. The moment they enable it, the first person who enables it becomes a member of privileged role administrator. It is not enough as a member of global admin to manage PIM. So if you want a Bob to help you manage PIM, you got to put Bob into privileged role administrator. Okay, so that's the role that you need to give if you want someone to manage PIM for you. Manage PIM involves configure role settings. Okay, do you have permanent assignment? Do you have permanent eligible? Do you have durations for the activations? So on and so forth. So you must belong to this role to be able to manage PIM. All right, I think this is a duplicate slide again. If you are planning on transferring a subscription to other identity, keep in mind it has to be Azure AD tenant user. All right. Okay. All right, PIM has a bunch of built-in security alerts. Now the link will take you to a set of common alerts. All right. Things like, hey, you got administrators who've been assigned privileged roles, and they don't need, okay, So yeah, assign privilege only to roles that needs that. Okay. The settings specify the maximum number of days that a user can go without activating a role. So if Bob belongs to this password administrator and he never activates in 100 days, does he really need to be there? Remember, the whole point of PIM is to make sure only the people who needs those roles are part of those role assignments, right? So PIM has all these security alerts out of the box. Right. All right. There are too many global administrators. Roles are being activated too frequently. That maybe you want to do a active assignment, probably, or give them a longer active duration. Another possibility. All right. So this is a list of all the security alerts that you may receive. Now, one of the security alerts is potential stale accounts in privileged roles. So this is going to bug you. Hey, you got an account. You haven't changed your password in 90 days. You're going to get this thing coming out of PIM. All right. So yeah. There's that. Now you can disable this alert if this is not your thing. For example, your corporate policy may say as long as you change your password once every 120 days, we are in good shape. All right. So you may just decide that you no longer want this to keep bugging you. All right. So you can go there and disable these alerts. All right. So keep in mind, these are PIN alerts. All right, and they primarily deal with people not assigned the correct roles or not using the role they're assigned to, and these other poor security postures. All right. Application permission. Now, when you are building an application to access Microsoft resources, your application can access resource on behalf of the user who's interacting with the program you're building. All right. That type of interaction means your application must receive delegate permission. Okay. Whoa. Without, I just realized I typed W. Okay. Now, many of these delegated permission will not require admin consent because the scope is such that the application will simply ask user to grant access to user-owned resources. The user simply delegating the web app to do things otherwise the user will do themselves. All right. So, for example, I may want scan my calendar entries and send myself a reminder of some sort, whatever. So calendar is my resource. I want the app to scan it for me. So I can consent to those apps. So delegated permissions are typically granted by user consent. Now, of course, if you're a directory admin, application admin, global admin, you can consent it on behalf of the entire organization. Okay, so that is possible. Not a good practice, but it can be done. Now, if you want application to be able to access resource on their own, okay, these are what we call service applications, daemon applications. Okay, so these applications that run on their own, they need to receive permission to themselves without an interactive user. So these type of application permissions are generally requires admin consent because no one is going to interact with them to give them a consent. Okay. And in turn, once these application is created in your Azure AD, you can prove. So your application needs two pieces of data: app ID and either the app password /secrets or a certificate to be able to receive a JWT for this application's identity. All right, so this all takes place in Azure AD application registration. Now, now you don't have to be a developer. Okay, you don't have to know all the nitty-gritties about how the protocol stands, token, etc. But if you are managing the directory, you have to understand the implication of an admin consent. Okay, so do not give it lightly. Okay. As whenever you do an admin consent, you are consenting on behalf of your organization. Most of these permissions are very, very dangerous. Okay, for example, you may consent a malicious app to access every employee calendar or emails. Okay, it's just one consent away. All right, so to grant a tenant-wide consent to an application, this admin consent is an all or none approach. Okay. Now, by the way, to consent for the entire organization, you need to be global admin, application admin, or cloud administrator. So these are the three things you need to be. All right. All right. So keep that in mind. And once you grant that consent, application can then make calls into access your organizational resource. And usually those things are called Microsoft Graph APIs. So what you're granting is their ability to access Microsoft Graph APIs. All right. Now also keep in mind the application may request multiple permissions. When you click that button to grant the consent, you're granting all of the consent. Okay, you cannot pick and choose and say, well, let me look at this app and I want to consent to this, I don't want to consent to that. Okay, you can't do that. When you do admin consent, you consent to everything. All right. All right. So you need to know the implication of when you consent access. All right, I think this is also a duplicate. All right, so gonna get rid of that. It's in part 1. So Azure Security Center let you set up auto-provisioning. Auto-provisioning describes the auto deployment of Microsoft Monitor agent. When you turn the auto provisioning on, it's going to deploy the agent to all existing and future VM under this subscription. Okay, so keep in mind that when you turn this on, all of your existing VM will enroll into the log analytics as well as new ones. All right. There's that. Auto provisioning makes paying bill that quick. All right. When you delete a user, don't worry, you can bring them back. 30 days. Now, here's where you gotta be careful. When you delete a security group, there's no soft delete. Soft delete is exclusively for Office 365 groups. All right. So make sure you know that there is no soft delete for Azure AD security group. You delete, it's gone. Okay, this is a security implication. I mean, you put stuff in the security group for the purpose of signing permission, right? And if you delete that group, you probably want it gone quickly. So it is not soft delete. However, Office 365 and user account give you 30 days to go. Oops, let me bring them back. All right, so if you're tasked to say, hey, Bob, I need some alert based on events you collect in Log Analytics. Well, there are two tools that can do it for you. Azure Sentinel can do it. Remember those rules? Those rules are just simply queries against those log entries. Azure Monitor create an alert based on log signals, right? So both of these can give you an alert based on the event that's collected. All right. When you have a web server, all right, so when you have a web server like this, your web server is going to carry a name like blah blah.azurewebsites.net when you first create it. Now, most of the times, if it's not something commercial, you can probably just live with it. Okay. But if you're hosting a website for your company, chances are that's not an acceptable name. You really don't want people to see, number one, you're running on AzureWebsites.net. Two, you're too cheap to buy a domain name to actually run it without the whole AzureWebsites.net business. All right. So we're going to take a look at how we can upload an SSL, run it on a host name that matches the SSL certificate. Okay, so I want to walk you through how this slide is relating to the web apps. All right, so my web app's done. So in the TLS SSL settings, this is where you can buy a certificate, upload one that you already have, take it out of the key vault if you have one there. All right. So there are many ways to do this yourself. Okay. Import an app service certificate. There isn't one issue. Too bad. You can upload one that you exported. Just remember triple des, triple des, triple des. So I said it 3 times. Triple des, triple des, triple des. When you export your certificate, it has to be encrypted in triple des using your password. All right. So after you upload it, you now have a certificate. You will then come here to bind the certificate to a host name. All right. So here is where you would choose a custom domain name based on the SSL that you uploaded. All right. So here is where you would specify the custom domain name. All right. So if you have some custom domain, there you have it. You can say I want, you know, to host an additional name. Okay. All right. Now, of course, app service domain is a broken state. You got to go there and do the business. All right. So what it's going to try to do is going to try to put this and CNAME to this AzureWebsites.net, so people can then visit demo.marseille.net, and you will still have the SSL binding to that custom domain name. All right. Having a certificate bound will allow you to establish SSL handshake. Occasionally in your code, you may want to retrieve the certificate for a variety of reasons, encrypting stuff. Okay. So if you want your C# code or your .NET code to be able to read the SSL private keys, you need to create an app setting. You can do that here. You'll say, I want a new app setting. And then you need to specify the thumbprint in comma separate values. All right. So there you have it. And once you specify these thumbprint, you can then use your code to read this app set to retrieve from that certificate store. Okay. So if you're a .NET developer, you know how to open one of these stores at machine store or current user store. If you're not in an isolated tier, you will access a user store. If you're in the isolated tier, the whole machine is yours, so you can access machine stores. This configuration makes sure your uploaded certificates are pushed down to the certificate store. All right. So there's a more comprehensive tutorial, and this is making the certificate available, and this is your C# code, and here is where you do your cert store dot certificates dot find, and your cert store is looking into the user store. Okay, store name dot local machine or machine, one of those. It's an enum if you're in the isolated tier. All right. So this slide shows you a few pieces of important things. How to push uploaded certificate into the certificate store, so your .NET code can use it to encrypt stuff, use that to sign things, whatever it needs to do. When you export a certificate out of your local machine, make triple sure it is triple DES encrypted. Even though you really want to pick AES 256, unfortunately Azure Web App doesn't support it. SQL always encrypt. Make sure the column value will not be visible to DBA, and the only way to make that happen is to never send clear text data into the table. All right. So a column master key that's stored either in certificate store or key vault is used to decrypt the symmetric key that's used to encrypt each column. All right, so column master key is the one that's stored outside of the database, and this is the one we want to make sure DBA has no access to. When you turn on this feature, the location and metadata about these column master keys are stored in a data dictionary, and if you're wondering which one it is, it's sys.column master keys. All right. It is application's job to get the CMK and decrypt the CEK, column encryption key. You'll get a symmetric key back to decrypt the rest of the columns. Now, if you are using .NET driver, that's all taken care of for you. You just have to make sure the application is allowed to retrieve the column master key. All right, so here is a JSON template where the point is to break down a key vault reference. Okay, so any resource in Azure has a resource ID, and you can usually find them under properties of the resource. All right, so there's your resource ID, eh? Okay, and you'll see resource ID follows a very common pattern. Subscription grid, resource group name, providers, yada yada yada, and there's that. All right, so when you want to make a reference to the key vault, we follow the same routine. Okay, in your template, and remember this is the parameter file. This is not your ARM template. This is only supplying the parameters to your ARM template. So keep that in mind. All right, so we have a way to reference a secret. All right. When this template is deployed, a virtual machine will come up. Username will be a demo user, and the password will be whatever is stored in the key vault. You can also inject a key vault secret using the configuration feature. So when you're in the app service, you define key value pairs, right? So sometimes you can define connection strings and other things here. Now, here's something to think about. If I put a database connection string, then whoever manages my app service knows my username and password to my precious SQL server. That's not a good thing. So what I can do is by using this reference, right, by using a reference to key vault secret. All right. So I can stick a key vault reference in the value. So if you come across this at Microsoft.keyvault secret URI, now you pull this from your key vault when you define the secret. So there's that. So what that does is that it prevents the administrator of the app service from snooping, hey, what's the connection string username and password? Naturally, your key vault must have an access policy that allows this managed service identity to read the secret. Right? So don't forget, just put that settings in there doesn't automatically give this app service permissions. You must give this a system assigned identity. All right, so copy that. And then you can go to your key vault. And then you can go to the access policy. And ensure that managed identity has secret permissions. All right, why is my monkey one disabled? Maybe I am not the manager. Okay. Well, this is not the time to worry about that. Okay, but the idea is you can reference these secrets in your web configuration. Immutable blob. There are many reasons why we want a blob to be immutable. You receive a phone call. Okay, we need to do an e-discovery, so we need to make sure you freeze all the files in a storage account. Great. So in your storage account, in your blob containers, navigate down to access policy. So it's a demo container, it's the access policy. There are two kinds of policy you can create using this interface. A stored access policy, which you use to sign share access signature with, or place blobs into an immutable hold. Okay. There are two kinds, a legal hold and time-based retention. So with a legal hold, as long as the hold exists, no blob within the container can be modified. When you have a time-based hold for X amount of time, you cannot change it. All right, so let's make sure your blob, make sure your blob cannot be modified by anyone. Okay. There we go. All right, so here's a poll and majority rules. Okay. Action that triggers advanced threat protection. I concur. It's whenever you add someone to the DB owner role. There's that. Bam. Don't need to look at distractions. All right, so global administrator, by elevating access, you can manage all subscriptions. So we talk a little bit about this on part 1. So keep in mind, global admin is just a directory role. By default, it cannot go out and start making resources to pay for them. Okay, remember, managing directory is not the same as paying for resources. Okay, just like you are in the human resource, you are there to manage all the employees and what they do. Your accounting department is the one that writes the check and buy the resources. So global admin is like the HR. Yes, you can fire accounting folks, but you cannot be the one that HR guys that go outside and start writing checks. All right, so global admin is the director role. Subscription owner is the one that spends the money. By elevating access, you can actually take over. So guys, watch out for the HR guys. They can take over stuff. So the global admin will gain access to the Azure tenant root, so they can make themselves as a user access manager, thereby make themselves the subscription owner if they like on all your subscriptions. So this is an example of all your base belongs to us, or something like that. Use Key Vault to store connection secret. That's keep in mind the step one, your virtual machine can use a managed identity to receive a secret from the Key Vault. Step 3, use the secret obtained to construct a connection string to Azure SQL DB. Now, using a managed identity on VM1 means the only way someone can read that secret is when the code runs on this VM1. So that means other people can steal all your source code all they want, even the compiled binary. That binary, as long as you make sure they don't run on VM1, they will never have a chance to get Key Vault. And they will not be able to construct the necessary connection string to access your secret data. So the end result of this is to ensure that only code executed on VM1 that have access to managed identity can access the connection secret. And in your Azure SQL database, when you have a contained user, the only way to authenticate against the user is by knowing the username and password and the database. You have to submit those two pieces of information to become that contained user. So you can take the password and stick them as a Key Vault secret. All right. If you see MDM, it stands for Mobile Device Management. The closest thing that mobile device that Microsoft now has is a Windows 10. Yeah, not very mobile. All right, so that MDM security baseline allows you to scan your mobile devices to make sure their configuration is cool. All right, so Microsoft has a service called Microsoft Intune. It can apply mobile device management security baseline to see if your Windows 10 is on the up and up. All right, so protect your users and devices. So they're essentially a bunch of Windows registry settings. All right, and I will set it to a secure default. All right, so there's that. Just-in-time VM access. Key point number one, it only applies to management port. It is not something that affects any other port. 22, 3389, 5985, 5986, that's it. These are the only port just-in-time VM's access will protect. Your virtual machine must have network security group or Azure firewall protecting the VM for this VM to be eligible for just-in-time VM access. If you don't have any NSG or Azure Firewall in front of it, Azure Security Center will not recommend you because this is not a machine that we can protect. All right, so when a user is trying to connect to a VM that has been just-in-time enabled, when they click on the connect button and say, I want to do SSH, they are going to see this message. Hey, you got just-in-time access policy. Click that button. All right, and once the request goes through, you'll be able to do SSH. All right. Bastion Server. Bastion Server, yeah. So it's a jump box. a jump box that's integrated into Azure Portal. Okay, so with the Bastion Server deployed in a VNet, Bastion Server goes into their dedicated subnet. Sorry, this Bastion Server has a dedicated subnet. All right, and any other VM within that VNet, okay, is now accessible to the Bastion Server. Note, it does not work with peer networks. So if you have a network peering with VMs here and VMs there, oops, it ain't gonna work. So it's not gonna work with peer network. So remember, peer network doesn't work. When you have a Bastion server deployed, when you try to connect to the VM, like that, I want to connect to the VM, you can stay within your portal, and in the Bastion server, you'll get an HTML5 remote desktop client. All right, so you don't have to open your VM to any public access at all. Okay, this Bastion server is designed to be secure, and all you need is a browser. So there's that. So keep in mind, can only provide access to VM in the same VNet and does not work with peer network. Now that of course can change if you click on this link. There is a voting process on that thing. How can we improve Azure networking? Bastion support VNet peering. We're currently planned for this as of more than a year ago. So yeah, smash that vote button. Right? Forget about this YouTube stuff. Not into YouTube. Don't smash nothing. Smash this vote so they'll bring the Bastion server to this network. All right, so folks, this is part number 2 of the exam prep for AZ500. Good luck.